The satellite and space area, industrial challenge area, is forecasted to be worth, it's about 400 billion by 2030 globally, of which the UK is looking to secure about 10% of that market, so about 40 billion. The area is of interest to the UK and the National Nuclear Lab because we have a potential disruptive technology. One of the things space needs and space and satellite technology needs is power. Power for electrical systems and power for heat. And we have a technology that can provide that power. This isn't just an NNL opportunity that we've been working on. We've been working very closely with University of Leicester, that's been bringing thermal electric technology to the system, and with companies like Airbus that provide the system integration and the system technology. Well, so far what we've achieved is we've been able to demonstrate that we can extract an isotope called americium-241, which forms in material up at Sellafield in the UK and is a waste. To the nuclear industry, it's a waste material, but it has a unique property in that it generates heat, and we can use that heat and we can generate electricity from it. So when you're in the cold and distant reaches of space, you've got a material that's generating heat to keep your spacecraft warm, and then you can use that heat to also generate electricity. So that is a very, very useful technology. And what we've been able to do in our laboratory at Central Lab is extract the americium from UK plutonium and show that we can do that, and show that we can provide that material as a fuel source.
This work is currently funded by Innovation, Research and Development, so that's internal funding within NNL, but it's undertaken in collaboration with Oak Ridge National Lab over in the States. So far the results look very positive. We've shown that we can achieve the separation of the two isotopes. We're now looking into improving that process further. Once we've actually done this on a large scale and really developed it all the way, this will be taken by Oak Ridge and done on a large multi-kilogram scale in May 2018. The ultimate vision for this work is that the Americans use our process to separate out some plutonium-238. This is then turned into a heat source by Los Alamos National Lab and ends up on a Mars rover in 2020.
So nuclear reactors have actually been flown on numerous missions, upwards of 30 missions so far, back in the 60s and 70s. But they were at much lower power in the sort of kilowatt range, whereas what we're looking to do is to produce a reactor and a spacecraft that can fly and produce about 1 megawatt of electrical energy. So this project is looking at using nuclear reactors linked up with an electric propulsion system to power a spacecraft into deep space, or look at return missions to planets. So the main aim of the project is to actually investigate the development activities and the prototypic activities that are required in order to achieve this sort of spacecraft. The development activities and the R&D requirements to test all of this system on the ground is something that the project is mainly focused on. And this is split into two aspects. You're looking at a ground demonstrator for a non-nuclear aspect and a ground demonstrator for the nuclear aspect. So the Democritus project is a European and Russia consortium funded by the European Commission and Horizon 2020 project. The consortium members consist of space agencies from across Europe and from Russia, and NNL are providing the nuclear expertise on the project.